Welcome to Civil Engineering Edge. In today's technical session, we will discuss one of the most fundamental and practical topics in concrete technology: methods of proportionating concrete mixes as per Indian standards is code. Concrete proportioning is not just about mixing cement, sand, and aggregates randomly. It is a scientific process of determining the correct quantity of materials to achieve the desired strength, durability, workability, and economy. In India, this process is primarily governed by IS 456 to 2000 and IS 10262 to 2019, which provide guidelines for nominal mix and design mix methods. Let us now understand these methods in detail. 1. Nominal mix proportioning as per is. The nominal mix method is a simplified proportioning approach generally used for small-scale constructions and lower-grade concrete, typically up to M20 grade. In this method, fixed ratios of cement, fine aggregate, and coarse aggregate are prescribed without performing detailed laboratory calculations. For example, M15 gives 1, 2, 4, M20 gives 1, 1.5, 3. These ratios are given in IS guidelines for general construction works such as residential buildings, pavements, and non-critical structural members. Key characteristics: no laboratory trials required, suitable for ordinary construction, simpler and faster method, limited control over strength and durability. However, the limitation of nominal mix is that it does not consider variations in material properties such as aggregate grading, moisture content, or cement strength. Therefore, strength achievement may not be very precise. To design mix proportioning as per IS 10262 to 2019 for structural concrete above M20 grade and for all major reinforced concrete works. Design mix is mandatory as per IS 456. Design mix is a scientific method where proportions are determined based on target mean strength, workability requirements, durability criteria, exposure conditions, maximum aggregate size, water-cement ratio, cement type. Step-by-step design process as per IS 10262. 1. Determine target mean strength. Target strength equals characteristic strength plus 1.65 times standard deviation. 2. Selection of water-cement ratio. Based on strength and durability requirements IS 456 durability table. 3. Estimation of water content. Based on desired slump and aggregate size. 4. Calculation of cement content. Cement equals water content. Water-cement ratio. Must satisfy minimum cement content as per exposure condition. 5. Proportion of aggregates. Based on aggregate grading and zone of fine aggregate. 6. Trial mix and testing. Laboratory trial batches are prepared and tested for compressive strength and workability. Advantages of design mix: more economical, better control over strength, suitable for high-rise buildings, bridges, dams, and industrial structures. Optimized durability. 3. Standard mix historical method. Earlier IS codes included standard mixes for grades such as M10, M15, and 20 with predefined cement content. However, this method is now largely replaced by design mix due to improved quality control requirements. Practical importance: for professional civil engineers and developers, selecting the correct proportioning method directly impacts structural safety, project cost, long-term durability, crack resistance, sustainability. In modern construction, especially for infrastructure and high-performance concrete, design mix as per IS 10262 to 2019 is strongly recommended. Conclusion: to summarize, nominal mix gives simple for small works up to M20. Design mix gives scientific, mandatory for major structural works. IS 456 and IS 10262 govern proportioning procedures in India. Understanding these methods is essential not only for students preparing for competitive exams, but also for practicing engineers responsible for quality control on site. If you found this technical session valuable, continue learning with Civil Engineering Edge, where we break down complex civil engineering concepts into practical, professional knowledge.